So first type, single mean test, right? So in this case, see, in this case the problem based on the size of sample, that is small n, that is known, and the size of population, capital N, is unknown. So this is the first type on large samples, right? Single mean test, right? We'll see the test procedures. So first we are going to define test statistics, that is Z test. A Z test is a type of hypothesis test to evaluate whether there is any significant difference between sample parameter. Sample parameter means sample mean, standard deviation, etc., and population parameter, mean, standard deviation, etc., or between the parameters of two groups. The distribution of Z test statistics under the null hypothesis can be approximated by a normal distribution. Always we are taking normal distribution for this test, right? Test procedure. So first step is to find the value of Z, that is the calculated value. So test statistics formula, Z is equal to x bar minus mu by sigma by root n, right? X bar is the sample mean, mu is the population mean, sigma is the population standard deviation, and small n is the sample size. In this case, if you know the population standard deviation, you have to use this formula, right? These are all the details. N is the size of the sample, sigma is the population standard deviation. So, or otherwise, Z is equal to x bar minus mu by s small s by root n, if small s sample standard deviation is known. Suppose if in a problem they have given population standard deviation, you have to use the first formula. Instead of population standard deviation, in some problem they have give sample standard deviation. So in that case you have to use the second formula. Instead of sigma you replace just s, right? Same formula, right? Step 2, so you have to define the hypothesis. So for one or two tail test with tabulated value of Z. So note that a standard normal variate Z lies between plus or minus 3. Therefore modulus Z is equal to 3. That is, Z lies between minus 3 and plus 3. So maximum value of Z is 3. Sometimes we will take this value, tabulated value, Z is equal to 3. These are all the hypothesis definition, right? So based on the level of significance. So critical region of two-tailed, right? Probability of Z is equal to Z alpha. Hypothesis we are taking null hypothesis H naught, mu is equal to mu naught. There is no significant difference between means. So alternate hypothesis H1, so mu not equal to mu naught. So these are the standard values we are going to take this. So at the 90% level, value is 1.645. So 95% 1.96 Z value, and 99% Z value is 2.58. These are all the tabulated value. Suppose critical region right-tailed. So probability of Z greater than Z alpha. In this case, H naught is, we are defining mu is equal to mu naught. There is no significant difference. But alternate hypothesis is you have to take the right-tailed. Mu is greater than mu naught. Here the value at 90%, 2.33. So you have to use these values, right? Whenever you are using right-tail. So 1.645, 95%, and 99%, 1.28. Last one, left-tailed. So if probability of Z greater than minus Z alpha. So here H naught is mu is equal to mu naught. There is no significant difference we are taking, but mu is less than mu naught. H1, that is alternate hypothesis. In this case the value is negative values we are taking instead of positive values. Right tail, you are just put negative sign in the right tail value. Minus 2.33 minus 1.645 minus 1.28. So we have to define the hypothesis like this according to the problem. Next we are going to conclusion. For two tails and right tail test, calculated value is less than tabulated value, null hypothesis is accepted. Calculated value of z greater than the tabulated value, null hypothesis rejected, right? But in the left tail test, this is just opposite to that. Calculated value is less than tabulated value, H not accept, because negative value, that is why. If calculated value is greater than tabulated value, H naught is accepted, right? So to find the confidence interval Ci, right, formula is Ci is equal to confidence interval x bar plus or minus z alpha. Z alpha is the value, right, tabulated value of z, sigma by root n. We know sigma is population standard deviation, x bar is sample mean, n is sample size. So suppose if sigma known, sigma is given, and that is population standard deviation is given, so you have to use the first formula. Suppose sample standard deviation they have given, then you have to use the second formula. Ci is equal to x bar plus or minus z alpha s by root n. So next we are going to find the standard error formulas. Standard error SC is equal to sigma by root n if population standard deviation sigma is given. Suppose if it is not given, instead of population they have given sample standard deviation, so you have to use the formula s by root n, right? The central limits theorem, sample standard deviation s is equal to sigma by root n by central limit theorem, right? Note that point also. First problem, a sample of 400 male students is found to have a mean height 67.47 inches. Can it be reasonably regarded as sample form? Large population with mean height 67.39 inches and standard deviation 1.30 inches, right? So normally they have the sample, they have clearly given, so sample size small n is equal to 400, right? Their mean height, whose mean height? The sample, right? So x bar they have given 67.47. so population, they are asking whether it is equal to that population mean and standard deviation, right? Can it be reasonably regarded as a sample from large population with the mean height? So population mean is, that is they have given mu 67.39, right? And population standard deviation sigma is 1.30. If it is from this population or not, just you check, that is what they are asking. That is, so first given, right, sample size n is equal to 400, sample mean x bar is equal to 67.47, population mean mu is equal to 67.39, and population standard deviation sigma is equal to 1.30. So define a null hypothesis H naught. So it is coming, there is no significant difference. That means it is from the large population with mean height 67.39 and standard deviation 1.30. We are defining, we are assuming the null hypothesis like that. That means mu is equal to mu naught. Mu is the population, right? Population. So mu naught is the mean from the samples you can take, right? You can assume right that. So mu is equal to mu naught. So there is no significant difference, right? So alternate hypothesis, mu not equal to mu naught. If you are taking mu not equal to mu naught, definitely it is two-tailed. Left tail, right tail, you know we are using less than and greater than. So here we are going to use, you can use any one, right? So better you can use two-tail test. If they asked particularly, then you have to use the right or left according to that. So two-tailed. So let the level of significance LOS be 5%. If they are not given any significant level, so you assume that it is 5%, right? So just to take 5%. You can take 1% also, 10% also, but the standard you can take 5 or 1, so keep it 5, right? So test statistics, we are writing the formula because sigma they have given. I am writing the formula, first formula, z is equal to x bar minus mu by sigma by root 10. Substituting the value 67.47 minus 67.39 by 1.3 by root of 400, so you will get 1.2308. This is the calculated value of z. So calculated value of z is equal to 1.2308. If you are getting minus, take the modulus value, right? So modulus that value, so you will get positive value, right? 1.2308. So tabulated value of z at 5% level of significance, right? From the table, so we saw the table, right? From that we are writing at 95% from the table 1.96. so we are going to conclude, right? So we are comparing the calculated value and tabulated value. So calculated value is 1.2308, which is less than 1.96, correct? Therefore H0 is accepted. Our calculated value always be less than tabulated value, then our assumption is correct, that is null hypothesis is correct. So null hypothesis is accepted. That means the sample taken from 400 persons with mean, right, is taken from the large population with mean, so they have given 67 point something, no, from that. So there is no significant difference between sample and population. Thanks.